Alright, today I'm going to try working on implementing variadic functions in Ion. So the reason is because I want to work towards being able to like create some bindings for C functions so I can call C from Ion. And you know, the first thing you want to call is printf, and so you need var args to do that. Um, the good thing about that is like I don't have to deal with like doing anything in the language with like variadic arguments. I can just pass them through. Like I just have to be able to parse them and like semantically check them and like in like a call statement be able to pass them through. Um, so yeah, let's see about doing that. So the first thing is gonna be parsing them. So like here's my test file. It's gonna look something like this. Like we have a function and I was just looking up in the C spec about like variable arguments. And so in C, I learned that you have to have, I mean, I don't use vargs that much. I've definitely used them before. I mean, you could see them in like our common. We use them for some like error handling stuff, right? So like I've used them, but not that much. So I don't have a deep understanding. But one thing I learned is that you have to have at least one argument before uh, the ellipsis that represents the variable arguments, which makes sense because like when you call VA start, you have to pass it that first argument so that it knows like when to start counting them as the variable arguments. Um, so there's that. This is what a prototype for a function will look like that has variable arguments. Is the music really loud? Sounds kind of loud. Alright, so the first thing we're going to have to do is be able to parse this. So, I think we're going to want a new token type for ellipsis. So let's start there. We go to lexing. Where's a good place for that? I don't know, just put it here. Is it double L? Ellipsis? I think it's double. Okay. So in next token, what do we want to do? So here, checking for dot. If the next thing is a digit, we have a float. Otherwise, token kind is that character. So I think this is the literal dot. So what do we want to do? I think what we want to do here is like else if um what match token. So that's 2 dots in a row. That's match token does advances the token, right? Wait, this is intended to be used by like parsing, or yeah, not the lexer. So so what do we do? Well, we're just gonna look ahead too, I guess. So else if stream one is a dot, then we're in here. So what we want to do is, check for the third. If there's only two, that's an error. If there's a third, then we have an ellipsis. So this is saying stream is that. So if the next one is that, then what I'm wondering now is just, do we have different errors for if... I mean, I guess we can catch that later as like a semantic error. I think what we want to do is to make it simple, just do if the next two characters in the stream are dots, then the token kind is token ellipsis, and then we need to increment the stream by 3 characters. Alright, that makes some sense to me. So maybe we run this and start stepping through to make sure that's working. You at least parse it. So test. And I mean, we're going to be looking at... Alright. So we're starting at the beginning of the stream. We get func, we get variadic, we get the ents, we get the n, exception, unhandled. Wait, what happened? Oh, I see. Right. So because the like lexer is being driven by the parser, like it's expecting when does expect token get called? Here. Oh, right, because this is fucking C, not ion. So I think this will still probably explode. So you're gonna get here and it's gonna be expecting a thing. So I wanted to just test lexing first, so let's maybe just do a lex test for that. So, you know, for sure. Honestly, we don't even need all of that shit, but whatever. So, you know, something like this. Func, variadic, open paren, n, colon ints, comma, assert token, token kind, or token ellipsis, right? So main, we're just gonna do, I just realized we're not returning under here, that's not good. Let's just run the lex test. Okay. Damn it. We should reorder this so that it's the first thing. Alright. So now we get the keyword func. We got a space. We got a name variadic. We got a space. We got an open paren. We got a name n. We got colon. Int, comma, space. Now where are we at? So we got the dot. The next digit is not, or the next, you know, character's not a digit, so we skip ahead. The next two are in fact, so we got the ellipsis. 3 moves ahead. Great. Cool. Oh, that works. Okay. So now let's check out parsing. So parse decal func param. Right, so what we're trying to do now is if we're parsing function parameters and we see the ellipsis, we know that's now variadic arguments, so we want to store that information somewhere. Do we store it in the declaration? Or maybe it's just in the parameter? Let's see. So for a func declaration, we have a bunch of parameters. So should it be stored here? And like... Seems like it might be useful here that so we don't have to like iterate the parameters just to see. Is variadic. Okay. So how are we proceeding so far? So you check it. So opening paren to start the parameter list. Till you hit the end, you're just parsing parameters. So get the name, which isn't now not the first thing you're gonna do. Um, so what I'm thinking now is like, how do we handle, if the variadic arguments are the first argument, do we handle that here, or do we do that out here? What we could do is just say, alright, for each parameter, if it's an ellipsis, well, you've lost the declaration here, haven't you? So maybe we want to do this out here. If it's an ellipsis, then this variadic is false. Is variadic through. We're gonna have to pass this, so like name params, length params is variadic. Guess what we could also do is say do we want to check for the error here? I have to like reformat this probably into like a for loop or something so I can keep track of the index to see if it's the first, but check here for this is a parameter seeding ellipsis. Alright, so now in declfunc we need to pass in where did we do that? Right after the parameter number. So num_params pool is variadic. Is variadic. Is variadic. Right. So let's think. Now potentially we can parse this guy. I mean, it's gonna fail on resolution, so I don't know, we could do a parse test. Actually, let me just do this. Yeah, printing's gonna fail too, but so yeah, that's interesting. How do we want to handle that? Do we want to pass in like well, if you're in the last parameter and it's variadic, you can just print the ellipses. So if I is equal to suppose this has to be 2 steps now, so if you're on the last parameter, if it's variadic, we just print the ellipses. Otherwise, we print just the name, and I guess you don't need that then. Oh wait, you do, yeah, for the type. Otherwise, it's just this. No, I guess we could have done this. So if it's the last one, it's variadic, we do that. Otherwise, we always do that. Alright, so we have the printer now. So this is the parse decal test. Let's just run that one. Okay. Maybe we just see we can run it. Yeah, variadic. Cool. So parsing this decal func, which is variadic. Start with false. First one, you're gonna get the first parameter. Second one, it is an ellipsis, so we say it's variadic. Get the block. Yeah. Okay. Alright, so we're parsing them. Great, so now we move on, I suppose, to resolution. So what's gonna happen? Maybe we just run it right now. See where we fail. So it runs. Alright, because we basically just do nothing with it. Okay, so, So there's two things we want to look into. So we're gonna have to do a call where you're like, call it. That just does Variadic with 69 and then 1, 2, 3. And I mean, we probably want to do different types and stuff, but since we're not going to use them, it doesn't really matter. It's just for printf, really. So that would definitely fail because we have a mismatch. And then definitely for code gen, we want to be able to spit that out. So let's just see where this guy fails. Not enough arguments passed. Not enough arguments? Alright, because we're probably just checking for equality, not like less than. Alright, so what do we want to start with? Probably the... Let's see, this will help. So, resolving an expert call. Sorry, I got this message. Okay, so, for call expression, right here. So we can't do this anymore. This is checking for strict equality of, um, so we're gonna do this. If it's greater than the number of parameters, then that's only allowed if it's a variadic function. Only allowed variadic function. Otherwise, if it's less than, that's always an issue, right? So yeah, that's this case. So if it's less than, not enough. If it's greater than, then interesting. The right now the variadic is on the declaration, right? We just have the expression. Well, we do have the resolved type, which is gonna have to carry that information, I guess. Type func, params, num_params is variadic, I guess, and a return type. Alright, so if it's greater than and the type is variadic, rather if it's not variadic, too many arguments passed to function. So then what do? I guess we're gonna still go through all of the parameters, resolve them. But we can't really do this type checking. So we're iterating through the arguments in the call, excuse me, and then checking it against the parameter in the resolved type. So, thinking we can do the same sort of thing we did when parsing, when it's like, okay, if you're on the last parameter of the resolved type, well, we're iterating through the call arguments, so we already know we'll never hit this if it's greater and it's non-variadic. So we can just safely say if the current index is greater than the type func num_params, which does it count the ellipsis as a parameter or no? I need to figure that out. I'm gonna look into that in a second. So I suppose you only want to do this type checking if it's less than or equal to. Well, no, because you still have the problem of the last argument. Like, if it's the last argument and it's variadic, then it won't match. So if it's less than, you always do the type checking. If it's equal to, Then you have to say if the type func is it's, hold on. Is it on the type or the type func? Okay. So this is wrong too. Type func. So if the type func's variadic, then rather, if it's not variadic, then you can check it. What happened? Okay. Seems ugly, but makes sense. Maybe there's a better way to do it. We can maybe clean that up later. Otherwise, if it's greater than, we don't do any type checking. Okay. We explode somewhere still. If it's greater than? Right, because we're not passing that to the type yet. We're just being dumb. So how do we do that? Well, when you resolve an expression that is, you call, or sorry, oops. It's in the type, so let's think about this. So when you resolve a call expression, you want to look up the symbol that's like the function that you're calling. Where does that happen? Probably in this resolve. Sorry, I was right there. Here, so this is gonna be like the name, probably. So yeah, semfunc. So we do a resolve declfunc. Right, so right here what's gonna happen is go through the number of parameters, but we still haven't figured out if it counts the variadic as a number of parameters, right? So yeah, let's just look at the declaration. Its name is Variadic. It has one parameter. I think we want to call it 2. Or, you know, maybe it makes it cleaner if we say it's just a 1. And then if you pass more than that, if it's variadic, that's fine. That might clean up the thing that was getting messy earlier. Let's take a look. So, where was that? It was in resolving a call, I think. So here, let's see. So if it's less than, not enough. If it's greater than, and it's not variadic, it's too many. Okay, so that's the way I wrote it. And then down here, go through all of the arguments in the call. And then you say if it's less than the number of parameters, then we type check. Otherwise, if it's variadic, we could just do it this way. Where basically you can just do, well, cannot type check var args do nothing. Suppose we just do this way and then assert that the type func is variadic. Okay, so it actually does seem to clean things up if you don't include the ellipsis as an argument, like in the count. So going back here, so we do all the parameters, then we say if decal, I mean, I suppose you can just pass it right here. Params, num-params, decal, func is variadic. Variadic. Okay. So that should work there. So now back in the, whoops, what happened? Sure, in resolve. Resolve decal func. Sorry, where did we explode last time? Type func. Too few arguments for a call. So now we're resolving type specs where you have this type spec for a function. Um, hmm. I suppose this also needs to have it, right? Like, so a type spec might show up in a place where you're doing like type defing, func pointer to some function that takes variadic arguments, maybe. So this is a type spec. I suppose you need to know if this is variadic as well. Okay, so we carry that through. So when do we create type spec func? We do this. Okay, now compiler should show me all the places where we do it. So we parse the type func. So yeah, this is the same thing as the, you know, our Steckle func, where we basically did this. All right. Then when you return it, right, but up here you have is variadic, is false. Here it changes to true. It's kind of hard to type quickly. Variadic. Here, type func, false. All right. So let's see about now. Well, now we run. Should be the same thing though, it's gonna just print out without the thing. Some things to note is enforce must be last argument. At least one param must precede the ellipsis, and it must be the last argument. So we're gonna want to do that. But anyway, in CodeGen, when we let's see, there's a few places, right? So type func is gonna be this for all the parameters. Put them all out. If type func is variadic, then we're gonna add to params a comma space ellipsis. Sure. Alright, we'll do it down here. Maybe we even do this. Spaces it out. Okay, so that's in gen type. We're gonna do gen type spec as well, which we can probably just copy. Whoa, what happened? Oh. Here, so func, go through all the parameters. If the type spec func is variadic, we put those out. What else do we do with that? So Gin decal or gin sim. Is there a decal func here? So parameters. Right. So if the decal func is variadic, we do that. I think that's all the places. Params. Oh. This is stir. So let's see. Nice. Variadic. Now has it. And the call works. Okay, so I think we have like the super limited version of variadic functions in. It might be worth just doing these now, so let's enforce at least one parameter must proceed. So let's do like this. Variadic fail. One. This should be illegal. And then this should also be illegal. Like int jint. So right now it just happily allows it, and interestingly, because we don't count it, it just reorders them for us. Huh, that's kind of cool, but it won't work because in a call, um, you're gonna rely on that being the in a different position. But so we want these to fail gracefully. So where does that handle it? I suppose that's in that's a syntactic thing. So in parse type func, parse decal func. So the easy one you can do is like, alright, if we're pushing another parameter, we can say if it's already variadic, um, do we have syntax error? Is that a thing? Yeah. So what's the word did you want to use for this? Like, no parameters can follow in a variadic. Something like that. So that should catch one of the cases. On line 3, parameters can follow. On line 3. Yep. Okay. The other one is you have to have one before it. Well, I don't think that's strictly true well, yeah, because we tested um in C, I think that's right. If we say a variadic function, does that even compile? No. Syntax error. I mean, these are weird. So let's at least give better error messages than they do. Sorry, true. If first that's a syntax error, um, at least one parameter must precede this in a variadic function. Hey buddy, what's up? How you doing? My dog came to hang out. What's up, poopy boy? How you doing? Okay. It did not catch it. We compiled, right? Yes, we didn't. Yep, so at least one parameter must precede in a variadic function on line 1. What is it? What you need? He wants to go out. What? Alright, well that's cool. So we got that. Some error checking. Do this. And like we kinda got that done. So well, I think I need to take him for a walk. So maybe stop there for now. That was at least you know, we got var arguments very basically in. That was super simple. I mean, that was basically nothing. But there we go.